Hello students and welcome back. Today this is again a lesson for 7th grade. So again, make sure you are a 7th grader watching this. 8th grade, you are working on something else. 7th grade, what we are doing today is we are going to go back to this lesson 13.2, which I said I skipped, and then we're going to move to it, which is all about perimeter of composite figures. So far we've been talking a lot about circles, circumference of circles, as well as area of circles. We're then going to move into talking about composite figures. And what are composite figures? How do we find their perimeter? How do we find their area? So only one I can today, and it's just I can find perimeter of composite figures. Okay. Again, warm up, we're just going to kind of skip. If you want to pause and give yourself a little challenge, see if you can get it right, challenge your siblings, go for it. I'm just not going to post the answer key on here. All right, so our essential question is, how can you find the perimeter of a composite figure? Well, the first thing to do this is we need to understand what is this composite figure, okay? Remember when we talk about perimeter, it is the area around your figure, okay? Not your area, I'm sorry, I rephrased it funny. It's the distance around your shape, okay? So in this case that you have a triangle here, okay? It's this distance right around it, okay? That's the only measurement that I want. Remember that your area means that this whole entire thing would be filled in. I want to know how much space this thing is taking up. So here is the definition of what is a composite figure. A composite figure is made up of triangles, squares, rectangles, semicircles, and other two-dimensional figures. Here are two different examples. So here's an example where they have a square, okay, as you can see here, and they also merged it with a triangle. Okay, so they're kind of stuck together right now. Same kind of thing you see over here. This time though, you have a rectangle and you have those semicircles, okay? Remember, your semicircles are going to be 1/2 of an actual circle. Okay? So then the directions here to find the perimeter of a composite figure, find the distance around the figure. So again, remember, finding your perimeter means that you are finding the distance around it. So I'm going to measure all of this distance around this figure. Try my best as much as I can. Again, this is a little hard to draw with. I will plug in a mouse here though, and hopefully that will help a little bit. Okay. So again, we're looking for the measurement all the way around these figures. So let's go ahead and take a look at some examples. All right. So the first example is asking me to estimate the perimeter of the following figures. Now, this whole entire thing is your direction, so make sure to underline it. Okay, and we'll circle or box in anything that else is important. The other big thing I would think that's important in here is your estimate. Okay, so it's going to be a guess. I'm looking though that your answers are fairly similar to what I get as my answer. Okay, and again, we are looking for perimeter, so that's that measurement around the shape. So these ones are on grids. Okay, when I'm going to find or estimate my perimeter, what I'm going to do is I want to find all of the boxes, okay, that touch this line. So I'm outlining the outside part because that's going to show me the perimeter here as best as I can. Okay, so everything that is those boxes that are touching this part of the line here. So I'm going to just pause the video for a second. I'm going to put a little dot at each one when I'm counting them along the way. Once I get done, I'll tell you how much I got. Feel free to stop this as well. See if you can get the answer before me. All right, thanks for coming on back. What I did here is I took the time to just pause the video and go through and count all these different sides that are touching here on the outside, okay? When I totaled all these up, I got 24 units. Okay, so double check here when you're talking about these diagonals. So it did touch this diagonal, this one, this one, this one. I didn't include these boxes because it only hit the corner. I wanted to be able to hit at least either a diagonal part or a full side of it. Okay. Another way, though, I could have decided on this is these diagonals can be about 1.5. So in that sense, 2 of these would make 3, 2 of these would make 6. So I could say that this side is 6. So maybe you got an answer that is 28. And that's fine as well. Okay. Again, it's an estimate. Just think about the reasonability of your answer. Is it reasonable to say that it's 24, 28? Is 16 reasonable? To me, I think 16 is a little bit too low. Okay, if you came up with something like 32, I think that's a little too high. Okay, remember you're only going through and checking off the ones that are around the outside here. Okay, so my next shape, I'm going to do the same thing. I'm going to take the time to dot them, make a good estimate. Now, it's easy to tell on some of these flatter sides how many boxes it's touching. So in this case, I've got 1, 2, 3, 4, 5, 6. To make it a little easier on myself counting wise, I'm going to go ahead and put a 6 here, and then at the end, I can just total up the sides. Okay. This one looks to be that it is 2, so I'm going to count this one as 2. All right. Now, remember I was telling you about diagonals. You typically, if they go straight from the middle to the middle, so if you've got a little box here, sorry, middle to middle, I meant corner to corner. So if they are going from corner to corner here, typically this is going to be a measurement of 1.5, okay? In this case, though, okay, this one looks to be going all right, but maybe if I combined this one and this one, because it's slightly off, it doesn't look quite as long. Maybe this one and this one could be considered as 1. Maybe this box and this box could be considered as 1, okay? So maybe on this side I'm going to put 2. 3 might actually be an even more reasonable answer. In this case, I think I'm going to put a 2. This side is about the same, so I'm also going to put it as about a 2, okay? When I total this up, 6 and 2 and 2 and 2, I would get 12 units. Okay. Again, maybe you got 14 units, maybe you got 13. Those are also fairly reasonable, okay? If you're getting things like just 6, obviously you only counted up one side, so make sure you're counting up every single side. If you're getting things like double this, probably not reasonable as well, okay? Do not just look at it and guess. Take the time to count it and make an educated guess. Okay, that's what estimating is. All right, so let's go ahead to the next part. Your next part is an on your own part. So take the time to do the exact same thing that we were just doing. Estimate the perimeter of the figures. Okay, so again, estimating, make a good educated guess. Take the time to dot your boxes. Check how many there are around the edges. Okay, go ahead and pause the video, see if you can get the correct answer or an answer at least close or reasonable to mine. Okay, I'm going to take the time right now to pause the video. When I come back, I will have all the answers. So go ahead and pause the video. Alrighty, welcome back. Here's what I have achieved so far on each one of these problems, and I wanted to kind of explain my thinking and how I got some of these answers first before we come up with the total perimeter. This first shape, what I did is I took the sides that are either a horizontal or vertical line. In this case, we've got a horizontal line, counting up each single box that it counts, okay? So I got 7 on this side is the same length, I also get 7, okay? When I started taking a look at then these ones, okay, my diagonals, so I've got 1, 2, 3, 4, 5, 6, 6 sides here that are diagonal. Now remember when I was telling you about these shapes, if you've got a little box here, okay, and you go from corner to corner to make a diagonal, this is usually going to be then a 1.5 measurement. Okay, this stems back to figuring this out using a thing called Pythagorean theorem, which is something that you are going to learn next year. Okay, it means that if I take this side and this side, okay, so this could be my A side or B side, they are each going to measure 1. So there's a formula within Pythagorean theorem that states a squared plus b squared equals c squared, where c is always going to be your longer side of your triangle. Okay, only works for right triangles, which in this case is a right triangle because it would have a 90 degrees here. Again, this is more stuff that we will learn once you're in 8th grade here. The biggest thing to just realize is these diagonals are going to be about a 1.5 measurement, okay? So when I had 6 of them times 1.5 gives me 9. This is where I'm getting this 9 from, okay? So I take the minute to add these two up. Well, I know 7 and 7 is 14. 9 and 9 is 18. So to get those together, that would give me 32 as my answer. Okay, so 32 units. So then your second one over here, now there is something kind of tricky about this one because it's got nice straight corners. Okay, in this case you were seeing ones that have kind of these little diagonal corners, okay, little ones. These ones are nice and straight, and what happens is that you need to make sure that you double count those ones in the corner, okay? So again, what I did is I just kind of measured each side and labeled the amounts. So on the top part here, you can see that I've got 5 different boxes, okay? Now when I go and count this side, if I just look at this side part, I have to think about every single box that touches it, which is 8. I have to include this corner box, which looks like I've already counted it on this side as well, okay? Same thing kind of down here. All right. Again, with my diagonals, this time I have 5 diagonals. Remember, each diagonal is the same as 1.5. So if I take 5 times 1.5, it gives me an answer of 7.5. So that's where I'm getting this 7.5 from. Okay. When I add these up, I can add my 8 and 5, 8 and 5, okay, that gives me 13. 13 plus 3 is 18. 18 and 10, that's, or sorry, 16. Woo! 8 and 5 and 3 gives me 16. Gives me another 10, I have 26. And then if I add in this 7.5, okay, that is going to give me 23.5. Again, if you're getting something very close, like 24, 25, 22, okay, those are very reasonable answers as well. Okay, hopefully I did my math wrong. Correct me if I did it wrong as well. But just, I'll go back and double check. 8 and 10, that's 18. 18 and 5, 23, 26. Yep. Add in that 7 again. 23.5. Okay. Let's keep going. All right, we're actually moving into looking at these composite figures within and outside of those grids, which I feel like right now this is a perfect time to pause this video, seeing as I can only make videos up to about 15 minutes. We're at about 13 minutes right now, okay? So I'm going to pause this one. I will make a second one. Please make sure that you are looking for as well part 2, okay? So rejoin me here on part 2. Find that next video. I will see you in just a minute.